Hey, the average Joe here, hoping you're having a fantastic 1st of March today. Today, we're going to look at the pump head and static pressure calculations or summaries in a system. I've had a few new users just say, hey, what can I do just to get started to look at a few things in building a system? So a couple ways, obviously, you could go to File and you could import the load data in, or you could just hand input it in, and that's what we're going to do today is hand input. And here's my space. So this project was built just by using that wizard. And when you go through and use that wizard, it asks for the heat loss of the space in this little gym project that I modeled here, wonderful Jackson Hole, Wyoming gym. 30,000 was the CFM needed, 400,000 BTUs of heat loss. There's the temperatures. I want 10% positive pressure, about 200 people in the space. So there's the heat loss, there's my temperatures, there's the 30,000 CFM of heating and cooling that needed. It's a no exhaust in there right now. Pressurization, I made that 10%. Keep the doors a little bit positive. Ventilation, I did an ASHRAE 62, and I went in and did the gymnasium, did the 200 people. It also looks at how many CFM per person for ventilation. So basically with that data, then it obviously built my air system here, how much air is needed for the ventilation. There's my 30,000. So now to look at the static pressure in this system, we just click on a fan, right click, and I look at my path. I say, yep, that's the path that I want associated with my calculation. And here's the summary of internal things. If I did not like the dirty static pressure of a filter 0.8, I make that maybe 0.1. The point was 0.8, or let's go 0.9. Okay, I could have done 1.0. So now I have a new summary. There's external static pressure, the duct right there. If you click on that, it'll take me to the duct data. And then it also shows you on the diagram which duct is related there. So in that duct, then I put in the duct length of under key data, 200 feet. We took a fitting factor of 50%, so used 300 feet, multiplied it by the static pressure, then added that to the summary. I could have gone in and put actual fittings in the system if I wanted to look at that as well. So now with all that information, obviously I can just come in, look at stuff internal, external, and then I see the summary down here of 2 inches right there, which you kind of see right there. That would be the heating, static pressure, and the cooling. A little bit different because there's a little different components that are in your winter heating or your summer cooling. You see how I clicked on those scenarios at the bottom. It shows the different CFMs and temperatures and whatnot. So that's the fan static pressure. The pump head would be the same thing. Click on the pump, look at the path. It's primary, secondary system. There's the primary pump. Here's the secondary pump. That's what I want. So now I look at my major items, coils, things, the head associated with that, the minor things, head associated with that, then my piping. So I have 2 pipe head losses in there. So what I did is I looked at the length of pipe from the pump clear out to the coil, and I put that length right in here, 100 feet. And then I looked at the length of the coil all the way back from the coil to the pump and put it right in there. And all those items add up to the 38 feet of head, my 27 GPM. You notice since I do have a condensing boiler, I did quite a large delta T here. If I go in there, you'll see my head. Let's just make that a 40 degree on a typical system. Now you'll see my flow is going to what? It's going to like double, right? So, if you want to do a lot of what if scenarios, now I can go in, I could look at the selection of a pump at the larger delta T, right, and see how that horsepower and efficiency compares to the one at the smaller delta T. Kind of see what I want to do on that. So that's basically what we want to do, is just look at the static pressure calculations. They're all editable. Typically what I do on a job is I'll send this coil, the air handler and the schedules to a local rep and let him do selection. Then he'll select all these items, and I'll come in and I'll say, well, he selected for that coil, 0.1 1 inch? Do I want to keep it at 0.25 or do I want to put 0.1? So then you can kind of put exactly what the selection's done. When we do selection of items in the software, then we can select fans and pumps and boilers. We don't do the selection of the whole air handler, but then you see that data immediately in the system. So when we do a selection of a boiler, just look at that on this pump, the key data, under the head loss summary, you'll see major and minus things on that boiler of 15 feet. Well, when it actually selects the boiler, it will look at the pressure drop of that boiler. We'll just go in here on that selection of the air-cooled boiler, the head loss. You look right here, and that head loss of the boiler is only 4 feet, 4.7 feet. So based on that, I could go back in and I could say, you know what, I want to only use maybe 8 feet or something for my head. Now you'll see that pump's going to go down the respected. So when you do a selection of equipment, you'll see the exact head or pressure drop of that, and you can make adjustments in the system to get closer to the head of your system. Anyway, hope this has been helpful. Let me know if you'd like this project. I'll send it out to you. And hey, thanks for watching.